Have you ever had a flat tire? In English, this is when your tire has lost air, maybe on the highway, and so it looks flat. The word flat has many meanings in English. But this tire is much worse than the flattest tire that you'd ever see from a car. This flat means that each of the sides is flat. This is a wheel which is in the shape of a convex pentagon, A, B, C, D, E, with side length AB is 10, BC is 10, CD is 20, DE is 10, and EA is 27. It rolls along the positive x-axis, where A starts at the origin. Which side will touch the point 2018, 0? This kind of question actually is also quite routine. Whenever you try to solve a problem like this, you basically want to know what is the circumference of the wheel, and then that tells you how many revolutions that you will have, and you look at the remainder. So it looks like I just have to calculate the circumference and do a division. Let's do this. The circumference is 10 plus 10 is 20, plus 20 is 40, plus 10 is 50, plus 27 is 77. So all I have to do is to take 2018 divided by 77 and look at the remainder. And that will tell me how far along this wheel I go. Okay, so it's a routine division problem at this point. If I want to do this, this gives us a chance to practice our tricks on multiplying by 11, actually. It looks like I should probably take 2 of these. And if I take 2 of these, 2 times 77 is 11 times 14. That's easy because I can write my 14 and put 1 plus 4, which is 5, in the middle. When I subtract, 11 minus 4 is 7, and 9 minus 5 is 4. Then I put my 8. 77, it's very not nice to divide by 77. I'll say 77 is about 80. And so I see that if I multiplied 80 by 6, it would be 480. It's pretty close, and this is a bit less than 80. So let's try 6. 6 times 77 is like 42 times 11. And so that would be 42 times 11 gives me 462. Subtract gives me a 6 and a 1. So the remainder is 16. And so what this means is that I go a full number of revolutions of circumference 77, and I have an extra 16 afterwards. And because each of these sides is 10 and 10, if I want to go 16, this tells me that I'll go up to here. And so this is the spot. It will hit BC. 2018, 0 will hit BC. The other way to do this is to simplify the division. And that actually is useful whenever you have a question like this that you're dividing by, which has 11s and 7s in it. And when the problem has something about a year, which is close to our current year, which is in the 2000s. You see, actually, I chose 77 very carefully on purpose. I already mentioned that there's an 11 here. There's a very beautiful number which comes when you multiply 77 by 13. 7 times 11 times 13. If I take 77 times 13, the easiest way to multiply would be to do this, because then I'll be able to write the same thing twice. 7 times 3 is 21. 7 times 1 is 7, 91. This is the 7 times 13, which is 91, which comes about very often. Since both of these are 7, I have another 91. And if I add this together, this is 1. 9 plus 1 is 10, carries a 1. 1 plus 9 is 10 again. 1001. How nice. 7 times 11 times 13 is 1001. This is a beautiful factorization. Now, I mentioned that any problem like this when I'm dividing, if I'm doing something with a year, which is around our current year in the 2000s, 1001 times 2 is 2002. So actually on this problem, 2002 is a multiple of 77 because it only has 7s and 11. It only has a 7 and an 11. And 7 times 11 times 13 is 1001. So I can immediately know that this wheel can make a lot of revolutions. And when it's finished with all of these revolutions, it will have gotten to the point of 2002, 0. A will have gotten to that point. And so actually 2018 minus 2002 is that 16. The 16 here is actually that remainder. So what I can do is once I recognize that there's a 77 in the problem, I can already deduct the 2002 and know that there will be 16. And so that lets me get the answer right away. Again, this problem is a fairly routine one, but I wanted to use it to share one of these beautiful factorizations that you may see again. 7, 11, 13 is 1001.